Hello and welcome to Mr. CFT. In this video I'm going to show you how to generate geometry and mesh of this product, which is a validation of a characteristic correlation for heat transfer over serrated finned tube paper. To begin, let's find fluid flow and drag it to blank windows. Right click on geometry box and select space claim geometry software. To start, we need to create XY sketch plane. And fit to window and draw 4 semicircles. Now dimensioning. Radius of bigger semicircle is 40.7. Smaller is 28.65, 21.65, and smallest is 19.05 millimeter. And with select line, we connect the line and exit the edit sketching. As you see, created 3 surfaces, and with pull button and enabling no merge, we pull them about 15 millimeter. And let's draw the teeth of fin. It's selecting surface. We should draw 2 lines and dimension it according to the paper. First distance is 3.07 millimeter and .5 for top of the teeth. Now exit sketching. For split body we need create surface. For that we click Ctrl+C Ctrl+V to copy surface. You see created surface, and with no merge button we pull it about 15 millimeter. Now we need pattern this. we select object to pattern and surface. We set 12 and angle 164.9. Okay, we need combine the teeth from other bodies. To do this, we select combine and select all body and then Saturn inter pattern, and now we don't need pattern. To split fin with domain, we need to create a surface and move it about 5 mm. And with split body module, we select the object that we want to split. Then select surface to cutter plane. Okay, now we need to draw a rectangle for domain. We hide plane, we don't need that, and create a new plane in XY direction. Create rectangle, dimensioning, distance between y-axis and right side is about 1000 mm. Y-axis with left side is 400 mm. The height of that is 500 mm. Now let's pull it with select and sketching. Automatically pull is on, and with no merge give it thickness of 15 mm. And we delete the surface, we don't need it. And we need to select type of merge with all bodies. Now our geometry is ready, and let's mesh this geometry. So close the space claim software. To begin, double click on mesh to open ANSYS meshing software. For start, click mesh, and it is CFD fluent. We set 0.008 for element size, and in sizing we don't need any change. We want a high quality mesh. To set sizing, we need to hide domain of fins and let's size. At first we need to size this line with upper line because the number of elements must be equal. Select number of divisions 6 4 2 and select hard for behavior. We generate mesh dissection to see if is it structure mesh. Yes, it is good. And now we want to set the number of elements in these lines. We select all lines in this body. Right click, insert sizing, select number of division, and we set 25 number. We don't want capture curvature and hard. The next step is set number of division for these lines. Again, right click and insert sizing. I'm sorry, we need to set number of division 12. Again, hard and don't need capture curvature. For set number of element for this two line, we need to know the number of element at the top line. For that we calculated, we have 12 line with 12 element and 12 line with 6 element. $216 elements. Okay. We set the number of elements for this two line. Set 10 element. Hard and okay. These two line. We repeat that option for these two and select generate. Okay. As you see, we forgot to set the number of division. We set element size, we found that. Okay, we fixed it to number of division, and the number of that is 10, and generate the mesh again. Okay, now we should sizing top side of the geometry. We need to add number of elements to the top lines matching the dimension we previously set for the bottom lines, and select top lines with holding Ctrl button and click apply to add them, and generate the mesh to see change in our mesh. Now we need add some sizing to the top line of the fin. Select outline with same length. Again, right click, add sizing with number of division of 10, hard, and no capture curvatures, and set the sizing for small line. And right click, add sizing, hard, no capture curvature, and generate mesh to see the new mesh. As you see, some part of our geometry were meshed unstructured, so we should add method and select, we want to select these bodies and apply. Select sweep method, add manual source, and select the surface of this bodies for source of sweeping, and set for all quad for structure mesh, and we need a high resolution mesh. For that we set adapting mesh and set zone resolution. Generate the mesh to see the difference. Okay, now all geometry. Full geometry is meshed structure. We forgot to set this sizing number of division. Set 5 for that, hard, and generate that. Okay, as you see, we have some increasing in the element size, so we don't need adaptive mesh, and set grow rate to 1.1 and click generate. So we fixed it. Now let's set name for boundaries and set boundaries condition. At first we set the bodies. For selecting the body of the fin, we select body select and choose the teeth of fins, and the body of the fin. Okay, right click, all of that selected, right click and create name selection and set fin. Now we should name the flow body, select the all flow and these. And we should select all of these. And right click, create name selection and flow. We named it flow. Okay. Now we hide flow field and select the surface of the fin. The surfaces we are selecting is the symmetry boundary conditions, and also include this to surface. Right click and name it symmetry or sim fin. Okay, now we should select wall boundary condition of fin. We select show full body of fin. For this we show, and again hide this body with F9 button. It is a shortcut for hide. Also select this and hide the domain part of the body. Okay, now select surface selection and select the wall surface of fin. We should select all surfaces of fin as a wall. Okay, all surfaces selected. Okay, now right click and select create name selection and enter wall fin. Okay, now we show all body to set the boundary condition of flow field. Select all of the surface and backside of it. And right click, select name selection, or for a short key select N. Set symmetry flow field. Now we should select heat surface as a heat wall boundary condition. And set the surface to outlet and inlet boundary condition. And apply it to add the surface to flow symmetry part. It seems we made a mistake earlier, but let's go ahead and correct it now. Okay, now our mesh is ready. Let's close the ANSYS meshing. Hope this video is helpful for you. To benefit from Mr. Safety services including simulation, consultation and training, visit our website www.mrsafety.com.